out the fact that there are three trees there. There would have been 5 here.
Anyone else's screen like really glitchy?
It could be. It could be that my computer's like doing 300 things. It could.
Okay, my bad.
Is it really, really bad?
Well, no, it just has do you know where you did the input 0, 1, 2, 3, and then first different, like the last page? It's like halfway through my screen and it's completely all glitched up and warped.
Oh, I don't know. It should just be an image.
I'll figure it out.
Okay. Should just be an image of mine, but there's 7, okay? So you guys are going to just apply this process every single time. If I put one of these questions in front of you, you're just going to draw table values, right? You're going to say, okay, well, stage 1 has 3 trees, stage 2 has 5, and stage 3 has 7. And then you're going to say to yourself, okay, well, how is that changing? Or how do we call this a first difference, right? And we're going to say, okay, well, it looks like I'm going up by 2s, right? Add 2, add 2. And you're going to say to yourself, okay, well, that's how the pattern's changing, right? But we need to figure out what the starting value is. Well, this tells me, remember, if you guys see that this is the same, if the first differences are the same, it's a linear pattern. Okay, if they're not the same, it's something else. We'll discuss that later, okay? But if they are the same, you can use this to figure out what this is, right? So the opposite of adding 2, if I was going up, would be to subtract 2 to figure out what the starting value was, which is 1. Okay? Which then makes your rule. You could write it out. You could say, okay, number of trees equals the stage number. We're going to multiply the stage number by 5 and then add the 1. Let's shrink this up. You guys can see. Okay. Now, if in the event, as you guys can see, it asks us how many trees are going to be in stage 43 or step 43. Are you going to want to sit here? And and what I'm trying to emphasize here is the importance of this, right? I think everybody could probably go, okay, stage 4 is going to be 9, and stage 5 is going to be 11, and stage 6 is going to be 13. Like, you could do that, right? Do you want to do that all the way to stage 43 is the question. No, you do not, right? So which is the purpose of this thing? Because if it asks you about step 43 or stage 43, you can simply take it and plug it in to where the stage number is. And now your equation or your rule is going to tell you the number of trees is equal to the stage number, which we are going to call 43, times 5 plus 1, right? Sorry, why did I put 5? How come nobody said anything? Why did I put 5? That's random. Sorry, guys. It's supposed to be a 2. Let me clean that up. Why is it a 2? Today's a long day. This is a 2 because of this. First differences go in for the 2's, okay? So, you could do the math on that. 43 times 2 is going to be 86 plus 1 is going to be the 87. Does anybody have any questions before I do the next one? Because if I just flip through here, okay, that's my way of getting you, right? that's my way of testing whether or not you guys know what's going on. And if I ask you how many trees in stage 111, for instance, or whatever number I decide to make up, right? It's not going to be 10 or something that you can just go plus, 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 plus. You're going to have to come up with the rule, right? Okay, it looks like what I'm seeing here. I just like to see people's equations, but really the hard part, I think the hard part about these is actually like the table. And once you do like 5 or 6 of them and you get the idea down, you know, you're just extracting information from the table and then putting it into a rule. Okay. It's a very nice tree, Caminella. Very nice tree. Okay. You didn't have to erase it. Okay, now let's go ahead. I'll scroll down here. And I just want to write something for you, okay? And I think most people should have seen, this is like, we have X's and Y's, like that's what a table of value is, right? Did everybody just see me write those? X's and Y's, right? When we have a table of values. Okay, we're gonna come back to that. Where Y is gonna be your output and X's are gonna be your inputs, right? So input, stage number, X, like those are all the same term or same thing. Outputs, Y's, number of trees, number of tiles, those are all the same thing, okay? Now, when I scroll down here, I just want to write a general statement that I think will help all of you with these questions. And I'm going to say the output equals the first differences multiplied by the stage number plus the constant. Okay, so before I've even written down what this next question is, okay, before I've even done the table, you're going to follow this every single time. Okay, and what we're going to learn is that that's going to be super annoying to write out every time, right? And you don't want to write that. Okay, and so some similar terms that I think we've all come across. I'm going to say the output, those are Y's, right? The first difference is, this is a little bit more of an interesting one. This goes by quite a few names. We have the rate of change. We have slope. This is going to be a key one for later. And slope, we learned in grade 9, was denoted by M. There's a few other ones that I'll come back to if I think of them. The stage number we can replace with X. Okay? And the constant we called earlier this morning, we called the starting value. Or you could call it the y-intercept. Okay? This is an important list that I think you're going to find useful as we move forward, right? So, sorry, you guys can't see that either. I'll move this. Okay? Now, I don't want to write this every single time, nor do you. So what I'm going to do is use some of these shortcuts, right? Where I say output is y. And then I'm going to say the first differences might be the slope, or M, right? And the stage number is going to be X. Okay, and the constant will be the y-intercept, which we called We called this B from grade 9. Okay, and so what you can write here instead is you could say, okay, well, output is denoted by y equals, slope is m, stage number is x, and the constant on the end is b. I hope everybody's seen that before. That's all this is. What is this thing? It's the equation of a line. Everybody freaking out right now? I hope not. Okay, so now let's actually tackle this question. This is what you're after in terms of what it is I'm asking you to produce so that you can use it. Okay, what do we need to do? Let's create our table of values. I've seen a few people with some answers already. Okay, that's okay. I'm going to label this X and Y. Input, output. Stage number. And dots. Or circles, whatever. Okay, and then we're going to have stage 0, stage 1, stage 2, and stage 3. Okay, in stage 1, if I were to count all these up, I'm going to see that there are 7 there in stage 1. In stage 2, I'm going to see that there's 15. And then in stage 3, I'm going to see that there's 23. If you were to count all these. Okay? You guys can't see. Okay. Now, you could apply your first differences and figure out how this thing is actually changing. Well, it looks like it's increasing by 8. Okay? And so if I were to try and figure out what my starting value might be, okay, then the opposite of adding 8 would be to subtract 8, right? So 7 minus 8 is going to be negative 1. There's your starting value, or your constant. Okay, I show you all these different terms because how could you have a... It's kind of hard for you to contextualize, even for, like, I can't contextualize what a constant of negative 1, like you're always losing 1. What does that look like with tiles? You're always losing 1, always losing 1. Like, that's hard, right? So we start to introduce these, like, these other terms that they mean something else. It's just a constant that floats on the end, right? And so instead of writing plus a number this time, you're going to have a minus 1 on the end, right? Or your b value is minus 1, right? Now what you have to do here is you're still trying to produce output equals the first differences, so the blue stuff, right? So anything highlighted in blue, the first differences we said was 8. Well, that has to go in for 8 for the m value, or the first differences, right? The slope. And then the stage number is x. That's your equation. And what it says is number of dots equals 8 times the stage number minus 1. So if I asked you how many dots are going to be in stage 43, then you're going to put the 43 in here, right? And so the number of dots, or y, is equal to 8 times 43 minus 1. Okay, that should be 343. Okay. So I really want to emphasize you guys actually using the equation, because just filling out the table is not going to be good enough, right? We're going to have to like, I'm going to for sure ask you how many of something are in stage 102 or stage 43 or whatever, right? You're going to have to come up with that equation. Okay. Does anybody have any questions with that?